Hello guys, trust you're doing fantastic. In today's video, we're going to be talking about the syntax for complement forms. Now, let's dive straight into the business of today. Now, we are going to begin with the syntax for 1's complement. Now, this is how simple it is to write the syntax. Now, you have a column where you have the sign bit and the first complement actual binary. Now, this is the syntax you need to follow when solving problems in 1's complement form. We have this example. Now, let's go straight to this example. It says, represent -7 in 1's complement form. Now, the question can come like this in your examination. So, the first thing you need to do is to understand the syntax I have presented here, where you have these two columns, you have the sign bit, which is the first column, and then you have the 1's complement actual binary. Now, this is also known as the magnitude bit. Alright, so the first one is called the sign bit, and then the second part is also known as the magnitude bit, which is the actual binary. So this is where you're going to be carrying out all your operations. Now let's begin with the question that says represent -7 in 1's complement form. Now the solution, the first step you need to do is to find the actual binary of 7. Now to get the actual binary of 7, we have to use this code, the direct conversion method, to convert decimal number to binary number. Now you have 2 raised power 2, 2 raised power 1, 2 raised power 0. Now we are conversant with this direct method. Since we know that the minimum bit required to represent 7 in binary number system is 3. So that is why we're using this direct method, where we have the highest value to be 2 raised power 2, so that we can have just 3 bits. Now representing that, you have for 7, it means the first one has to be present, which is 4. The second has to be present, which is 2. The third has to be present, which is 1. If you sum everything up together, you're going to get 7. Now remember, the sign bit for minus is 1. Alright, so we have the sign bit for minus, which is equals to 1. The next thing we need to do is to find the first complement, also known as the 1's complement form of 7. So the 1's complement form of 7 is nothing but taking the inverse of the binary numbers. So we're actually taking the inverse of the magnitude bit. So this is called the magnitude bit. So we're going to be taking the inverse of the magnitude bit. So if you take the inverse of 1, it's going to be 0. The inverse of a 1 is going to be 0. And the inverse of the last one is going to be 0. So therefore, the 1's complement form of 7 is going to be 0, 0, 0. So this is known as the complement, which is nothing but inverse. So at this case, once we have done that, now hence 1's complement form of -7 is going to be 1, 0, 0, 0. Now you're wondering, how do we get the 1? It's nothing but the sign. Remember, the question says -7. So it means that we need to assign the bit for the sign. So the sign, which is minus, takes the bit 1. So minus is being represented as 1. Alright, so that's why we have 1, 0, 0, 0, which the first bit indicates the sign bit, while the remaining bit indicates the magnitude bit. Alright, so this is the binary number for -7 in 1's complement form. So this is how simple it is. Now, since we have talked about the syntax for 1's complement form, now the next part we're going to be dealing with, it's going to be the syntax for the 2's complement. Alright, so let's begin. So it's the syntax for 2's complement. Now, just like the 1's complement, the formula remains the same. You have the signed bit, you have the 2's complement actual binary. Alright, so let's go straight to the example. It says represent -7 in 2's complement form. Now, like I explained to you, this is the direct method to convert decimal to binary. We have to use this. Of course, the actual binary of 7 is going to give us 1, 1, like I explained previously. Now we need to obtain the 1's complement of 7, which is nothing but taking the inverse of the actual binary of 7, which is going to be 0, 0, 0, which is the inverse, the complement. Now, since we know that the sign bit for minus is 1, hence the first complement for -7 is going to be 1, 0, 0, 0. This is very easy and straightforward. Alright, so let's go to the main path, which is to obtain the 2's complement form of -7. Now, to do that, since we know that -7, what we derive as the 1's complement of -7 is 1, 0, 0, 0. So in order for we to obtain the 2's complement of -7, it's going to be 1's complement plus 1. So it means that we're going to add 1 to the 1's complement that we have obtained. So that is the rule. So we're going to say plus 1 to the 1's complement. Now if you say 0 plus 1 in binary is 1, you bring down the 0, you bring down the 0, you bring down the 1. So therefore, the 2's complement for -7 is equals to 1, 0, 0, 1. Meaning that the first bit signifies the sign bit, which is minus. So this is how easy it is to solve problems in complement form. I want to encourage you to pay attention to the subsequent videos in this channel. Alright then, enjoy this video. Bye.